So the problem I proposed was to draw a 4-bar mechanism, and you can start out just by drawing any quadrilateral because you can change the dimensions of things after the fact in SolidWorks. The one thing to be careful of is making sure that your link lengths are perpendicular to the link rather than on the X and Y. So I can have the ground link 5 units is the problem stated in PowerPoint. Link 2, I make 3. The coupler link is supposed to be 4. And the output link is 5.5. Now at this point, it's still underdefined, which means that I can move points around. It deforms slightly. Generally speaking, it's good practice to fix your ground link, and it can be useful to have the ground link horizontal, although it's not required. The other spec I had on this thing was that the angle between the ground link and the input link was 35 degrees. So when I put that one in, it becomes fully defined. Now, I talked about, so there are various angles in this thing. When you did a version of this problem for the prerequisites, you found all these interior angles. We'll talk more about those angles, but this top one right here has a particular name. That's the transmission angle. It's a measure of how efficiently force is transmitted from the coupler link to the output. And so I can put a dimension on that one, but because it's fully defined, it says that one has to be a driven dimension, and that's fine. I can control that with my input link, and so the size of my transmission angle changes as I change my input. Now, if I hit save after I've done a drawing, it'll animate the motion, so I can actually see how this particular 4-bar is going to move just by drawing it up and then clicking on my input angle to change what it does. Now, there is something you have to be careful, because you'll notice that the transmission angle doesn't change by the same amount that the input angle does. There's a nonlinear relationship between those, and so it may jump a lot less or it may jump a lot more than my input angle does. And so if I want to hone in on exact angles for my transmission angle here, for what this is, as you'll need to do for your homework, you'll want to find the maximum value that the transmission angle can be. What you may find you have to do is you may have to drive this from the transmission angle rather than from the input angle. So I might have to delete that angle, and even though this isn't the input, if I want to figure out how big or small this thing can be, I can drive this mechanism from the transmission angle.